Hi, for this video, I'm going to talk about a robot that represents the kind of technology driving the fourth industrial revolution. The robot that I choose is Spot from Boston Dynamics. Spot is a great example of how modern robots combine sensors, computing power, and advanced movement to solve a real-world problems. For our robot identification, we got Spot. Spot is a quadruped robot, meaning it walks on four legs like an animal. Boston Dynamics designed it this way so it can move in places where wheeled robots would get stuck or fall over. Spot is about the size of a medium-sized dog, and it can operate either autonomously or manually through a controller. One of the reasons Spot is so well known is because of its smooth and surprisingly natural movements. The company has designed Spot to be modular. That means you can attach different cameras, sensor, depending on what a specific job requires. Because of that flexibility, Spot has become one of the most widely used mobile robots in industrial settings. For our purpose and benefits, the main purpose of Spot is to perform tasks that are either unsafe, physically demanding, or time-consuming for humans. A common use is an industrial inspection. For example, Spot can walk through a construction site or a power plant and capture photos, thermal images, and 3D scans. Doing this manually might take a team of workers several hours every day. Spot can repeat the same route with the same precision, which help engineers detect small changes over time. Another big benefit is safety. Spot can enter places that might expose workers to toxic gases, unstable structures, extreme temperatures, or other hazards. It's also valuable because it doesn't get tired, distracted, or inconsistent. When a robot does repetitive measurement, the data stays accurate from day to day. That makes it easier to catch early signs of failure or wear in equipment. Overall, Spot helps companies save time, collect better data, reduce risk, and improve efficiency. Next, for our sensors, one of the main reasons Spot works so well is the amount of sensing built into its body. Spot carries a set of deep and stereo cameras around its frame. This let it recognize obstacles, gaps, elevations, and surfaces. The robot doesn't just see in two dimensions, it builds a 3D understanding of its environment, which is essential for walking on uneven terrain. It also has an IMU, or Inertial Measurement Unit. This device tracks acceleration and rotation. You can think of it like a robotic version of a human inner ear. If Spot starts to lean or slip, the IMU detects that instantly, and that robot adjusts its legs to stay balanced. Depending on what the user needs, Spot can also carry a LiDAR unit. LiDAR shoots out laser pulses to measure distance. This helps Spot map entire facilities with impressive detail. Force and torque sensors are located in the joint of its leg. This let the robot feel how much pressure each leg is experiencing. This is why Spot can climb stairs, adjust its gait, and recover if someone pushes it or if the ground shifts. If needed, additional sensors like thermal cameras, gas detectors, 360-degree cameras, and radiation sensors can be attached. That makes Spot customizable for different industries. In summary, Spot is a strong example of what robotics looks like in the fourth industrial revolution. Instead of being limited to factories or controlled environments, robots like Spot can operate in a real world with complex terrain and changing conditions. It combines advanced sensing, autonomous navigation, and highly flexible movement that lets it do tasks that protects workers, increase accuracy, and gather data continuously. For future engineers, understanding robots like Spot is important because this system shows how sensors, computing, machine learning, and mechanical design come together. This is the direction robotics is heading, and engineers will be shaping the next generation of systems built on these ideas. That's all. Thanks for listening.